Okay, this video we're going to take a look at logarithms. So let's start with what we already know. We already know about exponential functions. So I'm just going to graph y equals 10 to the power of x. So we've seen this graph before. We know that when x is 0, y is 1, and when x is 1, y would be 10. Up here we'll have a point at 10. X is 1, y is 10. There we go. Okay, so there's our graph of y equals 10 to the power of x. Well, there's another function that's related to it, and that's a logarithm. And if I put in the function y equals log x, you can see that these points are actually flipped around. So this was the point 0, 1. Now check this out. Now it goes to the point 1, 0. And remember that point up there that was 110? Well, over here we have the point 10, 1. There we go. So all the x and y values in this exponential function get swapped around, and we get this graph here, which we call y equals log x. So this is an inverse function. Y equals log x is an inverse function of the function y equals 10 to the x. And in this course, we're only going to look at log x, which is actually base 10. There are different bases of log x. You can have base 2, you can have base 3, you can have base anything as long as your base is more than 0 and not 1. So for this course, we're only going to look at log base 10 of x, which would look like this, the inverse of y equals 10 to the power of x. And the other one that we're going to look at is, so let's get rid of this one, base e. So there's the graph of y equals e to the x. And the inverse of that function is a natural logarithm, which is alnx. So once again, the points on this one, let's see if we can find this. Okay, so 0.694 would be a y value of 2. So if I go to an x value of 2, I should get a y value of about 0.694. So if I go up here, yeah, pretty close there. Right. So they're inverses of each other. So lnx, the graph of lnx, which is the abbreviation for the logarithm, the natural logarithm rather of x, is like having a base e logarithm. So those are the two functions that we are going to work with in this particular course, lnx and log x. Let's take a look at, let's go back here and we'll graph y equals log x. And let's see what effect it has when we put a number in front of log x, like 2 log x. And it's probably not surprising to you that since we put a 2 here in front of log x, that our y values are going to be twice as big. So whatever the y value was here, it's now doubled. Here's a y value of 1. Now there's a y value of 2. Notice how this graph continues to increase. The graph keeps going up, 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 up. And as long as we keep that value in front positive, the graph's just going to continue to keep going up. Steeper and steeper and steeper. But if we start to make those that a value in front negative, now it is double. So here this was at an x value, a y value of 1. This was the point 10, 1. If I can find it, there it is. Now we're at 10 minus 2. Can't quite get it there, but you can see it'd be 10 minus 2. So it's still doubled, but now it's also reflected in the x-axis. It's been flipped upside down. And so what that's done to our graph is it makes our graph start to decrease. Our graph is going down. And as long as we keep that value negative, the graph's going to continue to go down, down, down. And the same would be true for lnx. As long as we keep the value in front of lnx positive, oops, the graph is going to continue to go up. But as soon as I make the number in front negative, now our graph is going to be decreasing. It's going to be going down. So to summarize, okay, here's the graph of y equals log base 10 of x, and here's the graph of just y equals ln of x. They're both increasing graphs. But if we put a number in front of either the log x or the alnx, then a few things are going to change. Whoops. So we can say that the x-intercept for every single one of these log functions will always be 1. Every single log graph of this form or this form will always go through 1 on the x-axis. The y-intercept simply does not exist. It gets close to the y-axis. We call that an asymptote. It gets really, really close to the y-axis but never touches it. So the y-intercept does not exist. The domain of a log function would be x greater than 0, all x values greater than 0. The range would be all real numbers, YER, goes down forever and continues to gradually go up forever. And then here's the key point. If this number in front of the logarithm is greater than 0, our graph is going to go up. And if our number is less than 0, the graph will end up decreasing.